In this video, we'll look at what is clean architecture when developing your web API. You may already be using clean architecture, but we'll be comparing the textbook definition of clean architecture to the actual implementation. Clean architecture is a design pattern that emphasizes the separation of concerns between layers, like the core business logic, database access, interfaces, and so on, to make your code more maintainable and scalable. The fundamental components of a clean architecture is the domain layer, which will hold the core logic and models, for example, the application layer, which will hold use case services and special data transfer objects, the infrastructure layer, which will hold access objects to external parts like your database, and the presentation layer, which holds the access points to your API, for example, the controllers. The advantages of using a clean architecture pattern is maintainability. It's simpler to apply changes to a focused, isolated layer. Testability. Because of the isolated nature of the layers, implementing unit testing becomes easier. Flexibility. External dependencies like databases and UI frameworks can easily be changed. Scalability. Each layer can be developed and scaled independently. Let's see how we implement this clean architecture. First, before we even start on the API, we need to create our domain, application, and infrastructure layers. The actual API that will present an interface to our application will be in the last layer, the presentation layer. So we'll start with a blank solution, and for our demo, we'll just call it Clean Arc. Once created, we can start adding our projects. Each project will represent a different layer in our architecture. We'll start with the domain layer. Right-click the solution and select Add New Project. The domain layer will be a simple class library. We give it the solution name followed by .domain. For our demo, we'll be using .NET 8. Our domain layer will hold the core fundamental entities of our application. In this case, there's only one entity or model class called movie. It has three properties, a default constructor and a specific constructor that we'll use a bit later when we create a movie object. Next, we'll add the infrastructure layer. This will hold the repository classes to access one or more of our databases. Right-click the solution and select Add New Project. Just like the domain layer, the infrastructure layer will be a class library. Here we give it the solution name, followed by .infrastructure. Please note these naming conventions are guidelines, and you may have called it .repositories if you like. You can delete the default class it creates and add two folders to the infrastructure project, named iRepository and Repository. Before we continue, we need a reference to the domain project. Right-click Dependencies and select Add Reference. Select the domain project. The repositories in our infrastructure project needs to reference the movie entity we created in the domain project. Next, right-click the iRepository folder and add an interface class called iMovieRepository. This interface can declare all the CRUD methods required for the movie, but for this demo, we'll just have a getAll method to return a list of movies. Next, we'll implement this interface. Right-click the repository folder and add a class called movieRepository. This class inherits from iMovie interface and implements the getAll method. Note, we're using a static list of movies here, just to simulate data on a persistent database. With the domain and infrastructure layers in place, we can create our application layer. Right-click the solution and add a new project. Like the others, the application layer is a class library. We'll follow our previous naming convention and give it the solution name followed by .application. Depending on your requirements, you may have more than one application layer in your system. For example, say you're developing an internal system for a large company with a sales department and an HR department. These departments may use different data services, and you could decide to use different application layers for each department. In such a case, you may decide to name the layer .application.sales for the sales department. But for our simple demo, we only need one application layer. Once created, you can remove the default class and add two folders called iService and Service. Also, we need references to both the domain and infrastructure layers. Right-click Dependencies and select Add Project Reference. Select the domain and infrastructure projects. As a demonstration, we'll be using a data transfer object. A DTO is often used when you don't want your service to return the entire model or entity, or you need to combine data from multiple entities into a new model. So we add a DTO folder and add a new class to it called Movie DTO. This model will have the movie ID, name, and a rating comment property. Now let's create the specific services for this application layer. Right-click the iService folder and add an interface class called iMovieService. The interface will declare only one method, the getAllMovies method. Notice it returns a list of movie DTO, not the original movie model. On a side note, remember these classes must be public to be accessible to the other projects. Right-click the service folder and add a class called MovieService. The movie service will inherit from the movie service interface class. In the constructor, we'll pass an instance of the movie repository so we can use its methods to retrieve the movie data from our database. In the implementation of the getAllMovies method, we simulate some basic business logic like making the movie name uppercase and setting a rating comment based on the movie's rating value. Finally, we return the new list of movie DTOs. Finally, we can add the presentation layer, or actual API, to provide an interface for the front end. Add a new project to the solution. This time we'll select the core WebAPI template. Here we give it the name .api. But again, as mentioned with the application layer, if you need to split your application layer into, say, application.sales, then you may also have an API dedicated to the sales department and name it api.sales, for example. But our little demo only requires one presentation layer. We're still using .NET 8 and enabled OpenAPI for Swagger. And of course, we'll be using controllers. Once created, you can remove all the weather forecast stuff that comes with the default template. First, right-click the API project and make sure it's the startup project. Then we need some references. Right-click Dependencies and select Add Project Reference. Select the application layer because it contains the services our endpoints need to call. Also select the infrastructure project because the services depend on the repositories to get the data. To use the repository and service with dependency injection, we need to register them in our program.cs. At last, we're ready to add our controller and API endpoints. Right-click the controllers folder and add a controller. Note we're selecting an empty API controller. We'll name it Movie Controller. In the Movie Controller class, we do some dependency injection to get to the application layer's services. Our only endpoint is a simple HTTP GET that returns the list of movies provided by the movie services. We're ready to compile and run this. If all goes well, Swagger should show your API with our one endpoint. When we execute our HTTP GET, it returns the list of movies. Notice it's the movie DTOs with the uppercase movie names and a good or bad rating comment. And that's our entire clean architecture solution. Initially, it may take a bit more effort to develop, but the maintainability and scalability of this architecture should become obvious. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.